This related rates problem, sand falling from a chute into a conical pile, altitude, I read altitude as height, so the height of the pile is always equal to 4/3 the radius of the base. Ask me two questions. First, how fast is the volume increasing, and it tells me how the radius is increasing, or what the radius is, and what the radius is rate of increase, or at what rate the radius is increasing. And then they give me the radius, and they tell me how the volume is increasing, and they ask me how fast the radius is increasing. So the first thing that I'm going to do is draw a picture of this thing. So I've got a cone pile thing. I'm going to label this as R. And then they say the altitude, so instead of going and labeling it as H, they tell me it's always 4/3 the radius, right? So I'm just going to label this as 4/3R. So now I'm going to set up my relationship. I want to relate volume, and because they're asking about volume a lot, and they tell me they ask me how fast the volume is increasing here. They're telling me the volume's rate, and they ask about the radius. So I want to relate V and R. I know that volume of a cone is 1/3 pi r squared, the area of the base, times the height. And remember, I know that this is the height right here. So I get V equals 1/3 pi times r squared times my height is 4/3 r. So that simplifies to volume equals, well, the 4/3 times 1/3 gives me 4/9. I'm going to leave the pi there, and then r cubed like that. So now that I have this equation, every time I do a related rates problem, I want to ddt an equation. So this one I'm going to ddt this. Now in the previous example, I used prime notation, but I think this is a good example to use ddt notation. So I'm going to ddt this equation, derive it with respect to t. So I get dv dt equals 4/9 times pi. That's my coefficient. Now, I'm going to derive the r cubed. I need to look at it as chain rule. I'm going to do r cubed, and I'm going to derive that with respect to t. So I get 3r squared, but I need to do chain rule and write dr dt because I'm not deriving with respect to r. Usually we derive things like on the right-hand side with respect to themselves, but not in related rates. So I get this dr dt. So this is actually going to go right here. I'm not going to rewrite it. So what I get, actually maybe I will. So this 3 is going to cancel in with the 9 and turn that to a 3. So my final equation for dv dt, and I'll write it over on the left bottom corner, is dv dt equals pi, actually undo, 4/3 pi r squared. Sorry, the iPad got jacked up there for a moment. But anyway, all that it missed was the dr dt. So I recopied a bunch of stuff from over here and put it here. So this equation right here, dv dt equals 4/3 pi r squared dr dt, is what I'm going to use to answer both A and B. So A, how fast is the volume increasing? That means we're looking for dv dt equals what? And then it says when the radius of the base is 3, so that tells me r is equal to 3, and it is increasing at a rate of 3 inches per minute. So dr, and by, does it say and it? And is increasing, so yeah, it does imply the radius. Dr dt equals 3 as well. So all I'm going to do is plug in 3 there and 3 there. So in for the dr dt is going to get a 3, and then the r inside of the r squared is going to get a 3, and then I'm going to solve for dv dt. So I get dv dt equals 4/3 pi. The radius is 3, so I get 3 squared, times dr dt is 3. So actually this and this cancel. And then I get that is equal to 4 times 9 times pi, which is 36 pi. Now, whenever I do related rates problems, I want to include units. So I look at this thing and it says how fast is the volume increasing. So I know that that's going to be, what are our units? Feet, feet cubed per, and then our time units are minutes, so per minute. That's my answer for A. I encourage you, if you're just watching this video, to try B on your own. See if you can figure out what is given to you and what is not given to you, and then hit play afterwards and see if you did it right. So, this one, how fast is the radius increasing? So we're looking for dr dt. When the volume is increasing, so that's dv dt, at a rate of 24 cubic feet per minute. And it is, that means the radius is, so r is equal to 6. So I'm going to plug in 6 here and 24 here and solve for this. So I get 24 equals 4/3 pi times 6 squared times dr dt. So I'm going to, I don't know, this is all doable without a calculator. I'm going to do it the way I would do it without the calculator. You can totally simplify it in different ways, but this is the way that I think is probably the easiest. So I'm going to rewrite this as 24 equals 4/3 times pi times 6 times dr dt. I want to keep the numbers as small as possible, so I'm going to separate them out. So first thing I see is I got, boom, this cancels with that and gives me a 2 instead of a 6. Then I can say, all right, that 2 divides into this and gives me a 12. Now I'm going to rewrite it, so I get 12 equals 4 pi dr dt. And I can divide the hold on a second, I forgot one of those 6's. So I'm going to divide the 4 into the 12 and get a 3. And now I'm just going to divide both sides by 6 pi. So I get dr dt equals 3/6 pi, which is going to simplify to 1/2 pi. And I should include my units, and it's feet per minute. So that's my final answer for part B right there.